everyone. Oh. No, not that. Come on. Sorry. Hey, hello, and good evening. Good evening, good morning, good day, wherever in the world you are. Welcome. Welcome to this Microsoft Reactor workshop this evening. My name is Erika, and I am the program manager at Microsoft Reactor Stockholm. Today, we've come to the 12th episode, and with a sorrow heart, we are going to wrap up this series today. Around the world of Power BI in 80 days, a journey through the data platform. This series has given you a 360 overview of how to use Power BI to build impactful reports. Through hands-on workshops, you've discovered how to transform and visualize your data and go from zero to hero, just in 12 weeks. Before we begin, I would like to have just a very quick word about Microsoft's Code of Conduct. We all come from different backgrounds, so please be aware of others, be friendly and patient, welcoming and respectful. After all, we are all here to learn. Thank you. Our host has prepared a big bunch of event resources that will help you to get the maximum out of your session today. So please go to the link above, aka.ms/reactor check-in, and use the event ID 14560 to receive these resources. I will also drop this in the chat just in a minute, just so you have it. But now, I say let me introduce you to our speaker today, Nikola Ilic. Nikola makes music from data. Da, 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 da. That's why he's called the Data Mozart. Power BI and SQL Server addict. He's a Microsoft Data Platform MVP, Pluralsight author, blogger, speaker. He's interested in everything related to data, and always eager to extract valuable information from raw data in the most effective way. He's got multi-year experience working with Microsoft Data Platform, SQL Server, SSIS, SSIS, SSRS, and Power BI. He's also a father of two, and if you have guessed, he's a true football fan. Go Barca, he says. But yeah, today, Nikola is going to examine potential bottlenecks in your Power BI report, starting with defining the best practices for data model size optimization, understanding the importance of query folding feature, all the way to identifying culprits for your slow report rendering. We will wrap it up with learnings when and why not to use DirectQuery mode, and how to apply improvements on data source side to make things faster in Power BI. I think this is going to be the perfect ending to this series. But I think I have now spoken enough. So let's have you here. Let's get me back here. Here we have. Hey, Nicola. Thank you so much for for being here today.
Hey, Erika. Hey, thanks for inviting me, and thanks for this nice introduction. Yeah, it was really nice to hear you.
Yeah, I actually wanted to do a bit of do more music, but I was like, yeah, I'm not the singer type.
Yeah, but it's better than me anyway. So thanks for this.
But yeah, this session is going to run for about 45-50 minutes, and then we will have time for questions at the end. But if you have questions throughout his presentation, just drop them in the chat. I will now switch off my camera, go to the background, but if anything, just give me a shout. I'll be listening and learning. Okay, you're up.
Thanks a lot. So as Erika said, good morning, good afternoon, or good evening, depending in which part of our planet you currently are. First of all, again, my gratitude to Erika and Microsoft Reactor team for inviting me, and I was given an honor to close this fantastic series, and I hope that you will enjoy our today's session. Just to add a few more sentences, Erika already told everything about me. So the first sentence is that I'm working as manager analytics for Avanade, the joint venture company from Microsoft and Accenture. And the other one is because I'm often being asked that why is data Mozart? So it's not related to my, passion about classic music or something like this. It's simple because I live in city of Salzburg in Austria, which is famous as a birthplace of Wolfgang Amadeus Mozart. That's the reasoning why I've chosen this nickname for myself. Okay, so I think we can start with the session. And in the very beginning, I will be honest with you. So creating a Power BI report may look like an easy task. So you import your data, you set those nice colorful visuals, and your shiny dashboard is ready. However, one day you get a phone call from the report user, and the user complains that her or his report is slow. Or even worse, your scary old DBA walks into the office and asks you to explain why your report burns all the available resources during the data refresh process. Or in the end, no one comes to you, but you're simply aware that your report blows the maximum limit in terms of memory consumption. As I've already told you, creating a Power BI report is not a rocket science. But in the end, there is a huge difference between a Power BI report that just works and Power BI report that works efficiently. Now, you're probably asking yourselves, if I have performance issues, if I see performance issues, where do I start? And that's a great question, because once you identify the area that causes problems, you are halfway through the solution. Okay, maybe not halfway, but you can then shift your focus to finding a solution to a more specific issues. There are at least 5 key areas to examine, and that we are going to talk about today if you want to improve the performance of your Power BI reports. First one is data model size, then is slow data refresh process. Next is DAX calculations. After that, visualization rendering time, and finally, last but not least, of course, storage mode choice. So let's go and try to understand each of these areas in more depth. And I'll try to show you some potential caveats and how you can avoid or overcome them. And I also try to share with you some best practices for getting the maximum performance from your Power BI report in multiple different scenarios. Okay, so the first thing I would like to discuss is your data model size. It's so important that in certain scenarios, for example, if you are operating on Power BI Pro license, which has a 1 gigabyte limit per data set, your solution simply can't be used if you reach that limit. Data model size also affects our second talking point, data refresh process. As you may assume, the larger the model, the more time and resources needed for the data refresh. Quite logical. So in the end, tabular model speed is based on keeping your data in memory, in cache memory. Thus, the smaller the memory footprint of your data model, the faster it will be. Now, to understand what affects your data model size, we need to lay some basic theoretical background. First of all, when you choose import mode for your data in Power BI, data is being stored in a columnar database, which is called Vertipack. Vertipack keeps the snapshot of your data in memory. And this snapshot can be refreshed periodically from the original data source. To understand how things work in the background, you should be able to at least be able to distinguish between Formula Engine and Storage Engine, 2 key components of this underlying architecture. Shortly said, Formula Engine represents the brain of Power BI. So Formula Engine accepts the request, translates DAX to a specific query plan, and that query plan consists of different physical operations such as joins, filtering conditions, aggregations, and so on. Then Formula Engine sends this query to a storage engine. Storage engine represents the muscles of Power BI, as it literally physically goes through the data stored in your tabular model. So if storage engine needs to dig through massive amounts of data, it would obviously need more time and resources. I'll try to give you a simple analogy. Imagine that you have to find a book in your old attic. What do you think? Would it be faster and easier to find it if you have just a few items around, or if your attic is in complete mess and full of all kinds of stuff. I think you know the right answer. Yeah, well, optimizing data model size is a wide topic that I also have a separate session, 60-minute session dedicated exclusively to it. So let me just quickly reiterate and list best practices related to data model size optimization. First one is reduce the data you are importing in your data model. The easier way to achieve this is to reduce the amount, reduce the number of rows and columns your users need in the report. Talk to your users and ask them what they really need. So before blindly put everything in your data model. That means remove unnecessary columns and unnecessary rows. How do you remove unnecessary columns? That's self-explanatory. How do you remove them? For rows, if you want to remove them, if you don't need data from last 10 years, but only 5 years in your reports, then simply import those 5 years. Don't import all rows that cover these 10 years. Next, this is also very important, try to reduce column cardinality whenever possible. In most cases, Vertipack database needs to use special encoding type which will build a dictionary for values in your column. And that means, to keep things simple, the lower the cardinality, the smaller the dictionary, and it will take less memory. So if you don't need, in concrete example, if you don't need data on a level of granularity lower than day, then simply remove time portion of the data, and that will significantly reduce the size of that column. I will show you in a few minutes in one example what I'm talking about. Next, avoid using calculated columns whenever possible. Simply said, they are not being optimally compressed. So they are compressed after everything is already done, and that's not the optimal way for compressing data. Instead, if you need to do some calculations, try to push them to data source side, like SQL database, for example, or perform them using Power Query Editor. Also very important, disable auto date time option when you load your data. If you're not aware, this will if you keep it, if you enable auto date time, this will create a bunch of automatical date tables in the background, hidden date tables. This way, by disabling it, you are also getting rid of those automatically created date tables. Instead, always create a proper calendar dimension in your data model. Okay, it's time for the first demo. So I want to show you one of these points in action when I was talking about cardinality. Let me show you how this looks in reality. So here I have a date time column. Let me show you quickly. So this is a table that contains 9.3 million rows approximately. And I have this date team start UTC table that goes to a second level of precision. So I have date and I have hours, minutes, and seconds. And this is just a simple measure that counts how many distinct values are in this column. So I have around 9 million values. Now, in 95% of cases, I would say you don't need granularity lower than a day. Maybe in some scenarios you would need hour level, but let's stick with majority of cases where you will need day level as the lowest point of granularity. Okay, so as I said, this column has cardinality of 9 million, but in order to follow what is going on with my data model size, I will use a fantastic free tool called DAX Studio. I really hope that you are familiar with this tool. If you're not, go to daxstudio.org and download it. It's free and it's full of very handy and useful features. So I can go and launch DAX Studio directly from Power BI Desktop. Of course, as a prerequisite, you need to have both of them installed on the same machine. So I will launch DAX Studio, and let's wait a few seconds just to connect to our instance of tabular model. On the left-hand side, I see all the tables from my data model, but now I'm interested to leverage Vertipack Analyzer feature within DAX Studio. Vertipack Analyzer basically collects different metrics behind your data model and shows to you here in DAX Studio in more readable, more convenient way. So how do you launch Vertipack Analyzer? I will go to Advanced tab here on the top. So here I will go to Advanced tab and click on View Metrics. Now I see that I have my 4 tables here, and you see different figures related to those tables. All those numbers here, just to be clear, are in bytes. So you can see that my chats table occupies something more than half of gig, so 550 megabytes. If I click on this small arrow next to a table name, I will see all those numbers broken down on a column level. So I can quickly identify which columns in my data model are the most expensive, how big is the memory footprint, how much in terms of percentage each of the columns occupies. So you can see that this DayTM start UTC that I recently shown you takes 82% of this table and 46% of the whole data model. That's really huge. And if you take a look, this column is 454 megabytes large. So it occupies 454 megabytes of our memory. Now, if I go back here and let me go to Power Query Editor, I will just get rid of time portion here and keep my day level of granularity. So I will just change type of this column. I can right click on this column, change type, and instead of date time, I will use date. So time portion disappeared. I will hit close and apply, and let's wait a few seconds. Hopefully a few seconds, not few minutes, for Power BI to reload the data and establish the structure again. So while we are waiting again, strongly recommend to download DAX Studio, one of my favorite tools for Power BI development, and it's really helpful for many scenarios. We will use it again later during another demo for testing DAX performance, but you can also use it for measuring the numbers and the memory footprint of your data model. So let's be patient, maybe like 15-20 seconds more. Now you see here we have like 9 million distinct values. That's cardinality of our column, so 8.8 million distinct values. And just keep in mind this number, 454 megabytes. That's important to keep in mind. Yeah, we are close. Now look at here. This value should be changed because we don't have 9 million distinct values anymore. And that should be it. So let's wait a few more moments. Okay, and it's instead of 9 million, it's 1,356. Let's reload our VertiPack analyzer, and if I now expand this chats table, you will see that this number matches. So it's 1,356 distinct values. And now this column takes only 6 megabytes. So just by removing time portion here, we reduced the column size by, I would say, 90-95%. So from 454 megabytes to 6 megabytes, just by removing time portion here. And that significantly reduced the overall data model size. Okay, so that's our first talking point. Now that you know how to optimize your data model size, your data refresh process will run much faster. Well, that's true, but not in 100% of cases. I mean, if that was simple as that, this session wouldn't have existed. So as I've already explained, VertiPack keeps the snapshot of your data in memory, and you are then refreshing this snapshot from time to time, depending on your specific business needs. It can be once per hour, once per day, or once per month, and so on. Now, chances are that you are applying some transformations to your data before you load it to Power BI, be it currency conversion or, I don't know, data filtering, renaming your columns, performing some calculations, and so on and so on. So where do you shape your data? That's the first question. Source database, that's the most obvious choice, and in most cases, that's the most desirable scenario based on traditional ETL, extract, transform, load processes. If you don't perform data transformations on the source side, the next station is Power Query. What is Power Query? It's the built-in tool within Power BI that enables you to perform all kinds of transformations to your data. According to Microsoft's official documentation, last time I checked at least, you can apply more than 300 different transformations, and that number is constantly increasing. The key advantage of Power Query is that you can perform complex data transformations with little or no coding skills at all. Additionally, all transformation steps that you applied during the process are being saved. So every time you go back and refresh your data set, these steps will be automatically applied to shape your data and prepare it for consuming via reports. Under the hood of Power Query is a mashup engine that enables your data shaping process to run smoothly. And Power Query uses very powerful M language for data manipulation. Now, for some data sources, such as relational databases, in most cases, but also for some non-relational data sources like OData or Active Directory or Exchange, Mashup Engine is smart enough and is able to translate this same language to a language that this underlying data source will understand. In reality, in most cases, it's SQL. Why is this important? Basically, by pushing complex calculations and transformations directly to a source, Power Query leverage capabilities of those robust relational database management systems that are built to cope with large volumes of data in the most efficient way. And that ability of Power Query's mashup engine to create one single SQL statement that will combine all M statements behind your transformations is what we call query folding. Or let's make it simple. If the mashup engine is able to generate a one single SQL query that is going to be executed on the data source side, we say that the query folds. Query folding is an extremely important feature in Power BI. One of my friends, Ben Watt, who is also Microsoft MVP, called it unsung hero of Power BI, and I really think it's an unsung hero of Power BI. Also deserves a separate session to get familiar with all the capabilities and limitations. However, I would like to show you today how this feature may increase or decrease efficiency of your data refresh process. Okay, so again, it's time for demo, and let's move on to Power BI Desktop. So I prepared a simple data model here for this example. We have only one table that contains around 12.6 million rows. Okay, so I will go again to Power Query Editor, and I will apply some transformations to my data. Okay, so this is the table without any transformations, 12.6 million rows. And let's apply some simple transformations here. So first I will grab, let's say, first name, last name, and gender columns from dim customer table to expand here. Then let's say that I want to transform this first name column to use only uppercase values. Okay, then I want to get rid of time portion here. So I will right click on the column, change type from date time to date. You see that, or you will see probably that, yeah, time portion disappeared. Now let's say that I want to calculate absolute value of sales amount. So I'll go to transform absolute value. I mean, this doesn't make any real life sense, but this is just for the demo purposes to show you how it affects performance of data refresh process. Then let's do some filtering, and I will, for example, keep only those rows where total cost is greater than 5. Okay, then let's get rid of ETL load ID column. I will remove this one. Then what else we can do? We can do some replacement, and I go to gender, and I will right click on this. I will use replace values, and let's replace M with male. And let's finally keep only those orders where sales amount. So I'm interested, for example, just in big orders, and I want to keep only those orders where sales amount is greater than 500. Okay. Now, how do you check if the query faults or not? If I go to this last step here on the right, so you see all of those applied steps. Once I save this file, every time I go and refresh data, all of these steps will be applied to my data set, and I will get data shaped the way I want. So if I right click on the last step, you see this view native query option down there. When this option is enabled, like in my case, that means that in 99% of cases, query faults. And I can see the SQL query generated by the mashup engine. Now, if you're coming from SQL world, this SQL statement may look awkward. Yeah, maybe there is a way to optimize it, to write it in more readable way. But in the end, mashup engine gives you a correct SQL. Not always the most optimal one, but it's correct. So you will get results you want. Now, if you take a look here, I'll show you. So we have our uppercase transformation translated to upper function in T-SQL. We have conversion. We have calculating absolute value. We have replace T-SQL function. So all of those M functions have their counterpart in T-SQL, and our statement could be translated. The most important thing are those where clauses. You will see. You will see why. So basically, we pushed filtering to data source side. In simple words, we will get already prepared and filtered data into Power BI. Let me show you this. So I'll close this, and let's hit close and apply. Again, we will need to wait, like, I don't know how much time, at 20. So hopefully it will finish until the end of this minute. And let's wait for Power BI Desktop to apply those changes and see how much records do we have now here. And after that, we will check what is happening when query folding is not in place. Okay, so it started loading. Okay. And you see that batches of rows are almost 70, 80,000 per batch. Just keep that in mind, because we will compare it in the next example and see how things changed in the meantime. Okay, so let's wait. Okay, so we have like 1.8 million orders with sales amount greater than 500. Okay, and it took around, let's say, 25-30 seconds to load data to Power BI. Now, if I go back to Power Query Editor, and I will now intentionally break query folding. So, of course, you should not do this, but this is just for the demo purposes. And this step where I change data type from datetime to date, I will delete this step. And I will now use another transformation that will break query folding. But in the end, I will get the same outcome, but now without query folding. Instead of using change type, I will go to transform and select date only. Power BI asks me if I'm sure that I want to insert the step. Yes, I'm sure. And you will see that we have exactly the same outcome here. So only date portion is here, time portion is gone. Now, if I right click on the last step, view native query option is disabled. That means, again, in 99% of cases, that query doesn't fold. And if I go and check all of those steps, this option is disabled. The last foldable step is this uppercase text. So here we broke the query folding with this step, but this one is foldable. So if I click again on view native query, you see that this uppercase was still translated to SQL and pushed to a data source, but all other transformations like absolute value, converting, replacing, and stuff like that were not pushed. And the most important thing, our where clauses were not pushed to a data source. So there are no where clauses here. And what is the consequence of this change? I'll hit again close and apply, and let's wait again. Again, when it starts importing data, I will check the correct starting time, and we'll see how much time do we need now for data refresh process in Power BI Desktop. Okay, so hopefully it will start soon. I'm always praying to demo gods when I'm doing live presentations, so yeah, sometimes it works faster, sometimes it's slower, but I think we are good with timings so far. Okay, so now it takes a little bit more. Okay, so let's wait a few more seconds, then I will switch back to a presentation while this runs in the background. Okay, so let's continue talking about query folding, and then we will go back to check if Power BI started to load the data. Okay, so let's try to list all the best practices related to data refresh process. I know that would be a complex task. Therefore, if you identify that your data refresh takes eternity to execute, maybe it's a good idea to check it. The first thing I'm going to recommend here for troubleshooting is a fantastic blog post from Phil Simark at dex.tips, where he explained how you can visualize your data refresh process and quickly identify potential bottlenecks. Some general practices in order to speed up data refresh process in general and keep query folding in place would be push your calculations and transformations as close to your data source as possible. For example, if you have permission to create a database objects, you can go and encapsulate all the necessary transformations in the database view and then import that view in Power BI. Keep in mind that views, same as regular tables, are foldable objects. So you can even apply another transformations to your views. Yeah, it's still waiting. I don't know what happened. Let's try again. I'll cancel this. Yeah, sometimes it happens, but okay, going back here to presentation. Also, keep in mind that query folding is not all or nothing operation. That means if you have, let's say, 7 or 8 transformation steps within Power Query and your query folds until 4th or 5th step, you will still get some benefit from partial query folding. However, once the query folding is broken, it can't be achieved anymore. Keep that in mind and try to push all your non-foldable steps. If you identify them, try to push them down this transformation pipeline as much as possible. Also, this one is important. Turn off allow data preview to download in the background. How do you do this? If we go back to Power BI Desktop, I think something is definitely not right here. But yeah, okay, so it's frozen now. Never mind. We will go back again later. One important golden rule regarding data refresh process, and if I have to choose one single rule, I call this one a golden rule. That would be push transformations and calculations as upstream as possible and as downstream as necessary. This is not my sentence. I picked that from Matthew Roche. Matthew Roche is one of the managers in Power BI, Microsoft's Power BI customer advisory team. So keep that sentence always in mind when you are doing some transformations to your data. Okay, now hopefully we are done with the background problems, background issues, and we are slowly navigating to a user interface. Honestly, that is the area of Power BI where performance issues are the easiest to spot. And as I said in the beginning, I'm sure that sooner rather than later, someone will come to you and say, hey, why is my report so slow? Of course, there can be a whole bunch of potential reasons, but let's focus on a few that are most often guilty for the bad user experience caused by slowness. Okay, so once you import the data in Power BI, I assume you will start writing DAX measures to satisfy different business requests. For example, you need to provide business decision makers with the metrics such as the number of unique customers or top performing products or running total of the sales amount and so on. The beauty of DAX, and I've intentionally put word beauty under double quotes, the beauty of DAX is that you can achieve the same result in multiple different ways. And of course, I will not go deep into DAX logic in this session, explaining filter contexts and the different functions and so on, as I'm sure that there were previous sessions with where my colleagues around who know DAX much better than I will ever know explained how DAX works. However, there are few certain situations where, you know, little nuances in your DAX formulas can take you in a direction that you wish to avoid. So let me show you one basic example of how misusing DAX calculations can cause a significant performance decrease in your Power BI report. Okay, so I hope that we will be able to know. So I will kill this and reopen my Power BI desktop file. That's the only way, obviously. Apologize about that, but yeah, it simply happens sometimes. Yeah, I know that something went wrong. Okay, let me open again this PBIX file. And while we are waiting, let me show you the measure definitions that we will check in Power BI Desktop. So we will use again DAX Studio. As I said, we will use DAX Studio to measure the performance of our DAX code. But in order to be able to do this, I need to have this Power BI Desktop file opened. Let's hope that it will happen soon. And then we can continue explaining problems with DAX. And I'm sure that all of us are facing those problems in our day-to-day work with Power BI. Okay. Few more seconds. Thanks for your patience. And sorry for not being able to show you the difference in query with the query folding and without query folding. The difference is in magnitude of data refresh process that runs without query folding is like 4 or 5 times slower than with query folding in place. Nevertheless, let's just do one thing that I need to apply. So I will go to transform data and I will keep only those sales, only those orders where sales amount is greater than 500, like we did in our previous example, because I need this filtered data for my next demo. I will go to this sales amount and I will keep only those rows where sales amount is greater than 500. Okay, let's hit close and apply, and let's wait again for Power BI Desktop to apply those changes. Hopefully it will work now after we restarted. Okay, so the idea is to compare data that is in Power BI Desktop and in DAX Studio, so we can confirm that we are retrieving correct numbers in DAX Studio by writing our own DAX, and then we will try to increase the performance of our DAX measures. Okay, so hopefully it will start loading it now. Yeah. Let's wait for 20-30 seconds. Yeah, it definitely works slower than usual. I don't know, but yeah, it simply happens sometimes. As far as I remember, we should have around 1.5 million rows in total, so we are close to this. Yeah. Okay. Okay, so now I will go here and just to compare those numbers here that we have. Let's go again to DAX Studio. And let me turn on server timings to see what is happening in the background when I'm writing my DAX query. Okay, so here is my first version of DAX measure that will return exactly the same data like we have here. Okay, so if I hit run here in the top left corner, let's wait for a few seconds for this query to execute. And first, as I said, we will compare results to confirm that we are retrieving correct results, and then we will try to optimize the performance of this measure. Sorry, again, this is wrong, so we need greater than 500, not 300. So again, I will rerun this query. In the bottom right corner, you will see the time elapsed for executing this query. So as soon as you see that the query takes more than a few seconds, that's the first sign that something is wrong with DAX and that the performance probably can be better. So this is already like 30 seconds, and we will try to examine what's wrong with this measure. I mean, obviously it took too long to execute. Just imagine the fury of your report users if they need to wait for a report to render in more than 40 seconds. So 47 seconds. Now let's go to results, and first I will compare the numbers. So it's 653, 785. Let's go to DAX Studio. Okay, yeah. So we are retrieving correct results. That's the most important thing. If I go to server timings, you will see that each of those queries took around 30, 40 milliseconds. So that's quite fast. But the problem is that we have more than 1,000 queries in storage engine. So what's wrong with this query? As I said, each of those single records are pretty much okay. But why do we have 1,000 different queries? Basically, that's understanding of how Formula Engine works. So it materialized data from a return from storage engine. Then after it materialized data, it ran a distinct count for every single set of data that we specified in our filter condition, date by date. So we have 1,097 dates in our data model. That's 1,097 queries that were ran here. Now, I guess you assume that there has to be a more optimal way to obtain the same result. So I will go and rewrite this measure. Let's put it here below so I can explain the subtle difference, but you will see the huge difference in performance. So again, I will run this good version, clear cache and run. And let's wait to see how long this one will take. So instead of 47 seconds, let's first check results to confirm, yeah, we are getting exactly the same results again. So instead of 47 seconds, now we have 128 milliseconds. And now we have only one storage engine query instead of 1,097. So what's the difference between two? Here we are filtering our online sales table, but we are filtering a whole table and then providing this argument that we want to keep only those rows where sales amount is greater than 500. In other scenario, we are just providing a single column as an argument. So instead of the whole table that has 12.6 million rows, we are providing just one single column and tell to Vertipack engine, give me only those rows where sales amount is greater than 500. There is also another way to write this measure. This is just a syntax sugar, so it should return exactly the same results. Again, I hope it's similar time. Yeah, 200 milliseconds. Again, one storage engine query. As I said, this is just a syntax sugar, omitting this filter all portion here. But basically, even if you don't write this filter all syntax, Vertipack will implicitly wrap your syntax with filter all and in the end produce the same performance or almost the same performance. And now remember when I told you that the beauty of DAX is the possibility to obtain same results in multiple different ways. So let me show you the fourth measure definition that will return the same results. This time I will use keep filters function. Just to be clear, and don't jump into some quick conclusions. Skip filters function is quite different than filter function, but for our scenario, it should return exactly the same results. We will check correctness of data. So if we go to results and sort this, no 300, it's 500, sorry about that, and clear cache and run. So you see that we have again exactly the same numbers as in our Power BI desktop report. In server timings, it's 140 milliseconds. Again, just one storage engine query. As you witnessed, we could have written one DEX measure to get the same results in at least 4 different ways. And this was just a basic example, but you could have seen the possible implications to performance. Key takeaway from this demo is if you need to filter data, don't filter tables, filter columns instead. That's the key takeaway. Okay, so, well, this one is, I think, the most obvious problem. When your report page renders slow, you can bet that the report consumers will complain about the poor experience and ask you to do something. So let's check what can be the root for the slow rendering. First of all, Power BI Desktop offers you a very handy built-in feature called Performance Analyzer. Performance Analyzer enables you to capture the different performance metrics for every single visual element on your report page. The rule of thumb is the more visuals you have on your report page, the longer time would be needed to render the page. And I want to show in a few minutes how this looks in reality. So let's go back to Power BI Desktop and let's turn on, for the beginning, let's turn on Performance Analyzer. You can go to View tab on the top and turn on Performance Analyzer. I will start recording now. One disclaimer here, in order to have completely correct results and exclude the data about the visuals that Power BI already loaded into a visual cache memory, we should go and create blank page, save our PBIX file with that blank page as the one that is displayed once the report is opened. But I will not waste my time doing this. I believe that results will be quite close, even if I just stop and start Performance Analyzer again. Okay, so I will start recording and I will hit refresh visuals here. There are different metrics that Performance Analyzer captures, so let's go and sort different report elements that we have here. I can sort by different properties. I'll use total time, and I want to sort this in descending order. Why I'm doing this? Because that way I can quickly spot what is the slowest rendering element of my report page. And I can see that this is this card, this one, total sales quantity, which took around 1 second to render. Now, if I expand this specific element, you see that DirectQuery took 100 milliseconds, which is quite fast, but you see that 90% of the time goes to this other value. Now you're probably asking yourself, what the heck this other means? This is a great question, so let me answer it. Other means how long did specific visual had to wait in the queue for other actions to complete before it could be handled. Don't forget that the formula engine works in a single threaded way, so it can't generate the DAX query for multiple visuals in parallel. So just remember that here we have 1 second as the slowest rendering element. I'll clear this and stop my Performance Analyzer. And now I will show you how this can be optimized without violating the original design of the report. So here we have 10 cards. Now I'm switching to another page that looks exactly the same. But this time I will start recording and I will refresh my visuals. And you see that the slowest rendering element is 375 milliseconds. So it's like 3 or 4 times faster than in the previous case. This time I spent some time formatting my visuals to look exactly the same like in the previous case. But this time, instead of having 10 report elements, 10 different cards, I have only 2 matrices. So each matrix has 5 elements in it. But for one matrix, we have only DAX query, or only one DAX query. In the end, instead of generating 10 DAX queries and waiting in the queue for previous 9 to execute, this time we have only 2 DAX queries. This idea, I need to give a credit for this idea to Chris Hamill from Microsoft. There is a great blog post he wrote on this topic. You should go definitely and check it. But the idea is to reduce the number of visuals that are generating DAX queries, and this way reduce the number of DAX queries that will be executed. Similar outcome can be achieved with a free custom visual card with states from OKViz, which you can download from the App Source marketplace. Going to list best practices regarding visuals rendering. Here is the list of things you should do or not do when it comes to performance of your visuals. Reduce the number of visuals on your report page. That's the most important thing. If you don't need a visual, simply remove it from the page. Also, having multiple non-data related objects such as shapes or images, icons will also impact the rendering time. So if you plan to have a lot of shapes and images, consider using PowerPoint. There you can create your desirable page design with all those icons and text boxes and shapes. Save this design as an image and then set this image as a page background in Power BI. Reducing the number of visuals on your report page also means that, like in our example, if you have a possibility to satisfy the business request by generating one DAX query instead of 5, you should tend to do it whenever possible. Next, try to display data at high level of grain. What this means, Vertipack is really brilliant in vertical aggregations, but performs much worse on a detailed level of reporting. With that in mind, if you have, let's say, a table with 30,000 rows and some measures being calculated for each row, you should be better off keeping this high-level detail by taking advantage of drill-through feature. So display aggregated data in the table by default, and then give user a possibility to drill through to specific row if necessary. If you have a lot of visuals on the page and don't necessarily need mutual interactions between those visuals, such as cross-filtering, for example, you should simply disable that option. Finally, sometimes sync slicers option can also be performance killer. If you have multiple slicers on multiple report pages and you choose to synchronize all of them, make sure that it's not the reason for your report's poor performance. Well, maybe I should have placed this issue in the beginning, as a decision which storage mode to use is one of the first you need to make when starting your Power BI solution. However, I've intentionally left it for the closing part of the session, and I've had a good reason for doing this. I saw a lot of cases when someone thought that poor report performance can be improved by switching to a direct query mode and leveraging capabilities of robust database management systems that are built to efficiently cope with large amounts of data. Oh, how wrong is that assumption? I mean, those systems are built to cope with large amounts of data, but in completely different scenarios. So before I explain why you should avoid using direct query, let me first explain what is a direct query at all. So when you choose direct query storage mode for your tables, this means that data is being retrieved from the data source at the query time. And this also means that the data lives in the original data source before, during, and after the query execution. So nothing goes in Power BI. Thinking that direct queries mode will improve your Power BI report performance is one of the biggest fallacies. Direct query will never ever improve performance of your Power BI report, period. To cut the story short, you should use direct query literally in 3 and only 3 scenarios. First, your data size is so large that you simply can't import it in Power BI. For Pro licenses, this limit is 1 GB per dataset. For Premium, I think this should not be an issue in 99% of cases. Next one is a requirement to have near real-time reporting solution. As we've already learned, when you use import mode, Power BI keeps the snapshot of your data. Now, let's say that the requirement is to have data with maximum 1 minute latency. Obviously, you can't refresh data every minute. However, don't fall here into the trap if your users request real-time data. Explain them all the downsides of using direct query mode, and from my experience, in 99% of cases, users will admit that maybe they don't really need real-time data. Finally, in those scenarios when security policies are defined on the data source side, as report consumers' credentials will be propagated to the underlying data source and security rules will be applied there. If I still didn't convince you to avoid direct query, or you simply must go this way. Here is the list of general rules that you should keep in mind in order to get the maximum performance from DirectQuery storage mode. The first thing is one huge if. So if you have permissions to perform changes on the data source, there are multiple ways to improve DirectQuery performance. First, you can create proper indexes to support your most frequently ran queries. Also, you should ensure that data integrity is in place. And finally, if possible, create persistent data objects in the database, such as tables, or even better, materialized views, which will persist all the necessary transformations and calculations. If you don't have access to an underlying database, you can still gain some improvement within Power BI itself. The most important thing is avoid complex Power Query transformations, as the SQL is that's being generated by the mashup engine is not always the most optimal one. It is correct SQL, but often is not the optimal one. If you need to use calculated columns, try to push their creation on the source database and keep them persistent there. Also, avoid complex DAX measures. Avoid relationship on GUID columns. GUID stands for Unique Identifier Data Type. Power BI doesn't support natively this data type and needs to apply some internal data conversion during the query execution, which affects the performance. Solution here is to convert this data type within the source database before Power BI generates its own queries. Limit parallelism and apply query reduction, also very useful techniques for improving DirectQuery performance. We covered a lot, and I think this is probably more suitable for at least 90-minute session, but let's wrap up the key takeaways from our today's session. The key thing is to identify which part or which parts of your Power BI solution don't perform well. If your data model size is large, consider removing unnecessary rows and columns and try to reduce column cardinality, like you see in our example, by removing time portion from your timestamp columns. If your data refresh process takes a while, check if the query folding is in place. In case that you identify the step that breaks query folding, try to push it down the transformation pipeline as much as possible. Be mindful when you write DAX to enhance your data model with additional columns and measures. For example, if you need to filter the data, always filter columns, not whole tables. Also, carefully use iterator functions, as they will apply calculations row by row. If your report page renders slowly, try to reduce the number of visuals on it. Always use Performance Analyzer to identify bottlenecks, and don't use many visuals that calculate single value, like card visuals, for example. Finally, stay away from DirectQuery storage mode whenever possible and use it in only those 3 scenarios we've already discussed. Of course, you should keep in mind each of these points, but if you ask me, one of them is slightly more significant, and that is the number one. Identifying which part of your Power BI solution is the root of the performance issues will help you to focus on solving a specific problem rather than wasting time on less important stuff. Okay, so that was it from my side, and I'm looking forward to hearing your questions, if there are any, of course.
Yes. Now you can hear me. Hey,
Yes,
thank you. Thank you so much for this session. We do have a couple of questions here. Actually, I think the last one is, what was this? Hello, Nicola. Where do you go to get Vertipack?
You don't go anywhere; it's provided to you. Yeah, when you are using Power BI desktop, one instance of analysis services tabular model will be spinned for you, and Vertipack is a database that stores the data for you within that instance of analysis services. So you are getting it by default.
Thank you. And then I think you have covered this, but let's just double check. Florian is asking if you can show again the 2 different data transformation on the dates column. Did you show this?
Yes, let me quickly go back to transform data. The one that's the one that caused problems for Power BI desktop file. So
Okay.
yeah, no problem. If you are using, if you right click on the column and use change type transformation and change it from date time to whatever type, it will keep the query folding in place. So this is the good guy. Let's call it like this. Change type is a good guy. If you go to transform and select date only, you will get the same outcome, but that's a bad guy. So don't use transform for keeping for changing data type. Okay, because it will generate a different M function in the background. One can be translated to SQL, the other cannot be. So always use change type.
Okay. Thank you. And if you guys have any questions, just drop them in the chat, please. In the meantime, I have one question. Oh wait, okay. Then I wait with my question. Aziz. Oh, hi, Aziz. Yeah, he's been here in this journey. I think, yeah, I've seen his name popping up almost, I think, every session. So hi.
That's great. That's great.
Yeah. So query forwarding also happens with data from Excel.
Unfortunately not. So unfortunately not. Data sources that are supported for query folding, you can find them on official Microsoft documentation site. But for you to keep in mind is there must be some kind of query language for that underlying data source supported, and there is no query language for Excel. So unfortunately, Excel doesn't support query folding.
Thank you.
No problem.
Okay. Okay, then I will ask my question now. Meanwhile, we wait for the next one. If you had a fantasy Power BI dinner, who would be your guests?
how many of them can join?
5.
Oh, that's nice. So Italians, Marco and Alberto, Melissa Coates from Coates Data Strategy. Oh, I'll forget someone. That's not good, but yeah, also my friend Tom Martens from Germany. He's also a tax expert. And let's say who will be the 5th one? Another lady. For example, my colleague from Avanad, Prati, she's data viz expert. So we will cover everything during that dinner. So all
Okay,
all
perfect.
aspects of Power BI.
All right, thank you.
Great question. Thank you. Great question.
We have one more question from Aziz, actually. Let's see. So, only query forwarding is applicable for SQL database.
Not only for SQL database, there are other sources that are not SQL that supports, like OData, for example. OData supports query folding, Exchange, Active Directory. Those are sources that are not SQL but supports query folding. But in reality, you can think of, yeah, like in 98% of cases, it's some SQL flavored data source.
Thank you. Okay, so we're waiting, and I have one more question, maybe less tricky.
Go ahead.
So throughout this past 12 weeks, I have asked every speaker the same question. Is that, as you know, this whole series is directed or targeting beginners at Power BI, and then we're building up their knowledge. If you were at that stage, or yeah, if you think back, oh sorry, I've just got a terrible echo here. It's quite bothering. So yeah, what would be your best advice to our audience? Like if it was you beginning again, how would you do it, or anything that really helped you throughout your years of experience that you think, okay, this is how I got here? Any just like secret tips, or oh god, this echo. Can you also hear this echo, or is it just really?
No, it's fine, completely fine here
Okay.
on my side.
Okay.
Well, if I need to pick one, it would be practice. Practice makes perfection. I mean, make mistakes. Don't be afraid to make mistakes. We all make mistakes. I make them every day now. Also, especially in the beginning. So don't be afraid to make a mistake. Don't be afraid to Google for solution. I'm doing it every day also now. So I mean, just practice, and that will definitely help you to improve your Power BI skills. Like for every skills, not just strictly related to Power BI.
Yes, it is very much true. You know, practice makes the master.
Yeah, exactly.
Yeah, thank you. We have a couple of questions here again, actually. No, Aziz is just saying thank you. And then, in case data and time are both important for view analysis, then what is your suggestion?
Yeah. So that's it depends. You know how that's always the correct answer. It depends. So it depends how big is your data model. Uh, if your data model is so large, then you can split date time column to two columns to use date column separately and time column separately. That will reduce the cardinality, that will reduce the overall data model size. But the trade-off is that you need then to rewrite your measures in the report itself, because you will need to combine those two columns instead of having one. And it's, as I said, it's a trade-off. If you have issues with data model size, you can split date and time, date portion in one column, time portion in another column. But if your data model is not so big, or if you have, I don't know, hundreds of measures to rewrite, then I think it's not worth splitting it. So there are solutions for both challenges, but it's about testing for your specific case what works better. But yeah, you can keep them both just by separating it.
Thank you.
You're welcome.
Okay. Guys, anybody have any more questions? If not, then we will let Nicola go and have his dinner.
Thanks.
So yeah, ask them now or never. Or obviously you can follow him on Twitter.
You can drop me a question on Twitter, yeah.
Or on LinkedIn, as I do.
Yeah, sure. Feel free, yeah.
Yeah, they say thank you, Nicola, and then lovely session. Well, okay. Well, thank you so much. If there is no more questions, then we will wrap this up. For the last time, actually. So, guys, thank you so much that you've been with us for the past 12 weeks. It's been a pleasure. It's been so good to see and welcome all the different MVPs and presenters. And yes, thank you, Nicola, as well, to be the series finale presenter.
Thanks.
It's been a great pleasure, and I hope to work with you again in the future.
Thanks. I would
And
like to. I would like to. Yeah.
yes. Oh wait, we have something else popping up here. Oh, good session. I had a
Oh,
chance to talk to you in the Data
data
Platform
point.
Summit.
Yeah, great to hear you. Great to see you again. Yeah. Thank you.
Yeah, so thank you guys. Have a fantastic evening or day ahead, wherever in the world you are. It's been a pleasure. Yeah, have a powerful winter.
Yeah. Happy Thanksgiving to
Bye.
all of US,
Oh
our
yes.
US friends.
Oh yes. Eat some turkey.
Yeah. Thank you all. Thank you.
Bye.
See you. Bye.
Bye.